Okay, so we're going to go down the design review. Anybody that says they don't need a design review is in for a harsh reality check. There's always contributions and suggestions that can improve the design. We'll go back to perfect is the enemy of good enough. We want to find that crossover point of cost and effectiveness, and providing the function of the part, meeting those specifications. All right, so I expressed my concerns as we were going through the geometry. We built the configuration that split this and um, reduced it down a little bit. So one of the things that if I'm going to start making some pretty significant changes is to go ahead and do a pack and go. So save as will save this, but it doesn't gather everything up. Pack and go. Don't really need the toolbox. I don't think we did any toolbox components. No results. Occasionally, yeah, it looks like it got everything. If we save to this PC, then I can put a A09 Rev 2 and select folder. It says it does not exist, so how about we Control C, new folder, Control V, make sure that gets selected. All right, so that should gather everything up, and we don't have any folders, subfolders, sub-subfolders, so flattening to a single folder is not a big deal. The main thing is that we want a snapshot of this geometry that if I totally screw it up when I go back through this, that I have something to fall back on. All right, so which one of these is open now? Can't really see my title bar, so the other one of interest is the find references. And so we're still in that Rev 1. So if I wanted to go to Rev 2, we'll just close all of that out, make sure everything gets saved, and you can manage manage the direction you want to go with revisions as you build into the geometry. All right, so now I know that this folder is in the Rev 2. If I look at the find references, everything should be tied to, except for, of course, our external retaining ring is still in the toolbox, which that was an optional item that we generated. All right, so design review on the block. So here's where the kind of a primary concern comes in with this design. Let's just go ahead and make a real quick. And so the stock that we start off machining, keep in mind that a good portion of these projects have been around for a long time. They were originally castings. The geometry was put in as in fixtures on manual machines. We're starting off with 18 pounds of material in the steel, and so with the aluminum and this being a hand crank, and that if I switched it over, I could make a pretty good case that I could lighten this up by quite a bit. So let's go 6061. And look at the mass properties, and this goes now to from 18 pounds to 6 pounds. All right, the main difference here is that, and my justification or my argument is going to be that, well, let's see if we can. I'm not getting that one. All right, not sure why I'm still in the mass properties. All right, so make sure you close your mass properties. So if I suppress that back, we're taking 18 pounds of steel or 6 pounds of aluminum, and we're reducing it again by half by removing all of that material. And then if I switch it back to the 1020, the mass properties goes to 8 pounds. So 10 pounds of material we're removing out of this thing. All right, so switching over to this, I did the split. I reduced the housing. You know, if this is my mount, then I'm okay. And on the drawing, since we did a little bit of the GD and T, our assembly envelope becomes a little more critical. That you know, the flatness, the parallelism, or flatness and parallelism, and then the flatness of the base, and being able to put those geometries in. We saw how there was a bit of an issue with, you know, if I put the threads on these components um, in the in the multi-body part, that the hole wizard, the tool, you know, what I was saying, the hole call out in the drawing can kind of skew those numbers a bit and make it a little bit confusing. So that's a concern. But the main thing is I can get stock that is 2 inches by, you know, 1 3/4. You know, might as well just go ahead and call it 2 inches by 2 inches by cutting off 2.5 inches, and square this up and make these parts as a manufacturing process, and I'm almost zero waste. You know, whatever I'm cutting it oversized, maybe 1 or 2% versus 50 to 60%. All right, but if this is, you know, gray cast iron, it's being cast in a sand mold, and you know, and that, then doing this final geometry is one thing, but making this out of billet, putting this on a CNC, I have, you know, I have pretty serious concerns. The other thing that was of concern, and if we go to the bushing call out, and you know, still have to do the stack up, but if I go to bushings, and we'll, you know, update the names as we need to, and go into that configuration. And probably think I can keep the split. We'll keep the relief and the bearing, and I'll just suppress those guys out. All right, so keeping this separate was handy in that respect. So let's go back over to our bushings. Bushings and bearings, and we want a plain bearing, oil embedded. We want a shaft for 3/4, and we're just going to download this. Now, if we're going to use these pretty consistent, I'm going to make a you know, a vendor folder in the design library so that I can use these in more than one place. All right, so the shaft for 3/4 inch diameter shaft, 7/8 by 7/8. So we were 2 inches. So you know, that one ought to be pretty good. 1,100 pounds at 60 RPM. We might be able to turn that 60 RPMs on our little hand crank, but 1,100 pounds, there's going to be some pretty serious mechanical advantage we need there. But the cost at $3, and if we're buying bulk, we're going to be able to generate that geometry. So the idea at 752, I could ream that hole at 750 to 751, and it would be a relatively you know, light to almost hard press. But let's go ahead and download one of those. Now it's going to put it into my downloads folder, so I'm just going to grab that real quick and cut it out of there. Put it over into our project folder for the Rev 2, and once I paste that, so you know, the OD went to 7/8, or the shaft ID was 752, and if we crush that, then Yeah, so I got those two reversed. So if we put a little bit of a crush on it, the 7, that precision shaft with the -3/10 to -5/10, that's going to have a nice running fit. So I, feel pretty confident that the whole basis on this bushing is going to be right where we want it. What I should have been looking at for the housing then is 877 with a minus nothing plus 1. So if I were to ream this at 7/8, then that geometry goes something like this configuration. And if we go 875, then we would have to do that stack up of tolerances again. But I have something that I could press one of these bushings from that side, one of these bushings from that side, and the carrier for that shaft now is way bigger than the 7/16 or whatever, and I still have an 1/8 inch of clearance in between. So getting those aligned might be a little issue. I might have to run the 3/4 ream back through both of them if there is any slight misalignment. So those are a couple of the concerns. If I decide to go this route, then I would probably want to save this as the um, output are solid bodies, save bodies. All right, so support cap and support base. And what else did we do here? If we go to the sketch, that one came out that side. Where did I make that adjustment at? I don't think. Okay, so there's the 0.88. All right, so that just rounded up. So I want to do this configuration 1 inch. So that would mean that I can buy 2 inch by 2 inch stock, cut it off a little over 2.5 inches. Would have to make the decision if I want to round. I would lean towards just chamfering that if it's a relief. The chamfer at least doesn't have anything special on the setup. So let's see that fillet. If I were to suppress that in this configuration and go to a chamfer, we could chamfer that. And realistically, with that extra clearance, might not even need to be the 2.5. So I can keep kind of beating this up as we go. All right, we get the idea on setting those out. If we save these bodies and we go ahead and auto assign the titles, all right, so it picks my name, browse, support, and we'll just give it the R2. So it has the assembly. Go ahead and save that. It should open up assembly. Drive parts unit set in its template to allow to update those. That was back to setting those default. All right, so showing me the preview. And then here's where we could use in our assembly features. No, this went back to the part. So make sure I know what I'm looking for. We'll save that real quick. Jumped over to the crank assembly. So let's just go ahead and close that because I'm expecting to generate some errors on this as I go through and mess with it. All right, so I'm in the assembly. This is a good place to use the whole series as geometry. So new. We want this side cannot be empty. No. So whole positions. Let's go ahead and place that. The top will be a countersunk for, let's see what a flathead 82 degree with a 1/4 inch. Yeah, that looks pretty good. Usually we'll put in just a bit of head clearance on those so that it does not stick up if we have the geometry. There's not really a middle hole specification, so, and the next piece will be the tapped hole, 1/4 inch, and the end component is that guy. All right, so if we go back to the positions, I should be able to do the center lines so that I can mirror these. And 4 is definitely going to be on the overkill side. Oh yeah, my previews is driven cannot change. Don't know why that would be driven, but okay. All right, let's, not sure why it's not letting me have that unless it picked up coincidence somewhere. 1 inch by 1 inch. All right, so 2's too little, 3's an oddball. Oh yeah, we probably don't want to do that. So we need a blind in condition, not through all. We'll go with the standard 15.42 inches. Yeah, probably not. Let's see what 1 inch looks like, if it'll let me generate that. And let's go to the hidden lines remove. So it did, yeah, I don't think I think I did something wrong there. It should have a little bit more of a stack up. So on that one, did that one go all the way through? Head clearance, normal. Yeah, I think that one's going all the way through too. So where is its blind? All right, so I've got to sort that one out. So the end component was that one. Yeah, I think I've got to go find out what I told it to do there. But it is showing at least the first step and the second step. So maybe that cured it. If not, we'll decipher it. But it's one possible strategy for setting that up. All right. So the advantage there is we save. We go back to our cap. Those migrate from the assembly back, but now we have 2 associativities, one coming from the multi-body part, one coming back from the assembly. So we're really not modifying anything in those 2 parts. So that becomes a little more interesting in the process. All right, so the next one would be the handle. Let's go ahead and pull up this guy. So we change out the body. We look at the going to the bushings. Probably I don't want to spend too much time on this, but this shaft and making the knob. We go back over to our vendor and we start looking for either the machine or lever. The advantage of the tapered lever is going to be that this is already a smooth revolving handle. So if I go with the 1/4 20, it's 2 inches, 1 9/16. So might need a little bit of an extension. We would see it doesn't go as far, but again, we'll do the download. It probably is going to bark at me every once in a while. This throws up a do not have permissions. So since I'm not seeing my download, all right, well, yeah, I've got the unconfirmed and it says it did it, but no, there they are. All right, so if we cut that one out, put it back over into our project folder, then we would be suppressing those and replacing, and then chances are this doesn't need to be that big. All right, so the other items was that I wanted to make this a little bit smaller, and if I made that a D shape, I could get rid of the key altogether. And again, for what it's doing, the loading, if I needed, I could potentially put a set screw on that end. The retaining rings with the bushings on both sides would keep it from sliding back and forth and in position. And then the spline, we would either go to a hex drive or square drive. I mean, there's a couple ways, but we still have to make that decision. All right, so we would go through and present all of those as an alternative, rebuild the assembly. Let's see if the support. Now I know the support is going to generate errors when I switch over to the bushings. It's a given. All right, so don't be surprised. Don't be overwhelmed when things start turning red and the mates are freaking out. That one didn't quite come over all of the way, but that is probably because that is still the part level and not the assembly level. So I think to be on the safe side, I would just go ahead and rebuild this. But once we've made those decisions, we've shrunk this material, we've made it more cost effective, easier to manufacture. Now we have something that we could go and prototype and see what our end results are. Okay, so I've implemented a few of my changes, and we'll kind of just discuss as I go back through the assembly. It took about I don't know, 15 minutes to make the adjustments. So let's grab the bronze bushing. It doesn't really do what I want it to do there, so I'm going to open, and these are usually older files anyway. So if I go, and if I'm going to be doing a lot of these, the mate reference is worth the time. Add that, so insert components, we'll browse back to the bronze bushing, hit tab, place it, grab another one, hit tab, place it. All right, so when I bring in the shaft, and I still haven't renamed the shaft, so we'll have to do that at the end. I went to a D drive, and there's no mate reference on that one, but I'm not planning on doing more than the one. So my concentracy, probably forego putting in the external ring. I added a second groove. I took away the splines and put in a flat, so when we get the pulley or the gear or whatever this is going to drive, we can look and maybe we need two flats. It's for a hand crank, I'm still having a hard time believing that this needs that much geometry. From a machining standpoint, the grooves and tapping the end and turning this end down, I turned this down to a 3/8 and put another flat. I also went about 10 thousandths under the thickness of the link. So on the link, it goes with. Oh, did I lose it? Or is it still thinking about it? Uh-oh. There we go. It took a minute to catch up. So I went with the D, and I call them Mickey Mouse ears, but it's a little circular relief in the corners that allow that's not going to be as sharp, and I'm not going to have to do anything. Since I'm drilling and going to take probably an 1/8 inch end mill anyway and go in and relieve those corners and make the D shape, then it's not going to be that much more to make sure that slides on. All right, so we'll meet that concentric. and rotate that to, those should be pretty close. Now I didn't do any stack up of tolerances. This would be, since we're making both parts, which one's going to be easier to control is shaft. I'd still kind of like to have this be on the light press side. It's just that when this makes contact with this, these sharps are going to, even if I hit them with a file, it's going to be harder to blend. And I'm going to end up with whatever size end mill, I'm going to end up with that as a radius transitioning from the flat to the cylinder anyway. And then we'll go coincident. And that looks okay. All right, the other thing that I added for this group was the 1/4-20 on the end, so that I'm not relying on that press fit as by itself. So I had just picked a standard. Let's see if we can find it here. Bolts and screws. Standard pan head Phillips screw. So machine screw. Can maybe rounded pan slot. Binding head. Well, let's just see what one of those looks like, and we'll go from there. Okay, so 1/4-20. I drilled it plenty deep. So probably a 3/8 just to have a little bit more. And we put that in place for our shaft. Oh, did I grab another one? Yeah, it looks like I got two in there, so we'll expand that out. And so we'll just have to watch those extra clicks. I'm going to place one. And then the last component was we were getting. I just think that the ball is going to be more expensive to machine or not as accessible. So if we get a purchase part or can pick a purchase part, then let's go with that. And so McMaster as a vendor really likes to put those threads on there. So maybe let's go with that one. And that one will be concentric. We should be able to draw that out a little bit. And those will be coincident. All right, so now we have something that as we turn, it does kind of the same thing, but I want to say just better material selections. Looking at the assembly envelope of the bushings, there's better support throughout. There's all kinds of little decisions that we have to make, and the customer may look at this and go, "No, you're out of your mind. I want the other one. I don't care what it costs." And like, "Hey, as long as you're writing the check, I'll build it however you want." But we want to try to adjust for this geometry. And even looking at this, it could go maybe a little bit narrower, wider, and I think as far as the height, pretty good. But there's always going to be little adjustments that you want to make, and it may be that whatever lever or whatever pulley drive belt thing on the other end, none of this is going to play out, or we're good with all of it. So we make those decisions, we present it for design review, and we make the case that this will reduce the cost and be as good or better, meets or exceeds the specification.